Another great paper, From Model-Centered to Human-Centered, Revision Distance as a Metric for Text Evaluation in LLMs-Based Applications. The rise of large language models, LLMs, has fueled a surge in AI-powered applications, particularly in the realm of writing assistance. However, evaluating these applications presents a unique challenge. Traditional metrics, like Rouge or BLEU, focus on surface-level similarities between generated text and reference text, failing to capture the essence of human-centered evaluation. This article delves into a novel approach, revision distance, that prioritizes the user experience and provides insightful feedback for LLM applications. Why human-centered evaluation matters. Current evaluation methods cater primarily to model development, optimizing loss functions in isolated environments. However, the true value of LLMs lies in their application, where user experience and utility take center stage. A simple numerical score, detached from context, fails to address the nuances of human perception and interaction. Imagine a scenario where a developer uses Rouge to evaluate LLM-generated text within a writing assistant application. While Rouge might indicate a high similarity score, it provides no insight into the actual user experience. Was the generated text helpful? Did it require further editing? These crucial questions remain unanswered, highlighting the need for a more human-centered approach. Introducing revision distance, mimicking human editing. Revision distance addresses this gap by incorporating the iterative process of user-driven text revision. The metric quantifies the number of edits a user would need to make to an LLM-generated text to achieve a desired quality level. This approach aligns with the real-world behavior of human writers, who often revise and refine their work through multiple iterations. The evaluation process involves two key components. LLM generator, LLMgen. This component, like the writing assistant, generates the initial draft text based on user input. LLM user. This component acts as a proxy for the human user, suggesting revision edits to improve the draft and bring it closer to a predefined quality standard or a reference text. Revision distance, therefore, is determined by the number of edits suggested by the LLM user. This metric goes beyond a simple score, providing detailed insights into the specific areas needing improvement. Putting revision distance to the test. To assess the effectiveness of revision distance, the researchers conducted experiments across two writing tasks. Easy writing task, this involved generating emails, letters, and articles, where existing metrics often reach saturation, offering limited differentiation between models of varying strengths. Challenge writing task, this focused on academic writing, specifically generating related work sections, which demand complex knowledge reasoning and concept understanding. The results showcased the strengths of revision distance. Easy writing task, the metric aligned well with established metrics like Rouge and GPT score, confirming its validity. However, revision distance offered a more nuanced evaluation, better distinguishing between the capabilities of different models. Challenge writing task, revision distance provided reliable and stable evaluations even when other metrics struggled. In academic writing, where knowledge reasoning is crucial, the metric demonstrated its ability to capture the essence of quality beyond surface-level similarities. Furthermore, the researchers explored the application of revision distance in a reference-free setting, using the ultra-feedback dataset. The results were promising, with the metric aligning with human judgment in approximately 76% of cases, highlighting its potential for scenarios where reference text is unavailable. Beyond scores, qualitative insights. A key advantage of revision distance is its ability to provide qualitative feedback through the analysis of revision edits. These edits can be categorized into three main types. Reference order revision, reorganizing the sequence of references based on different perspectives, such as chronological order or methodological approach. Reference comparison revision, integrating comparative discussions among references to highlight similarities and differences. Reference description revision, modifying the description of a reference, making it more concise or elaborate. By analyzing the types of edits suggested, developers gain valuable insights into the specific weaknesses of the LLM-generated text and can focus on improving the model's capabilities in those areas. The future of text evaluation. Revision distance represents a significant step towards human-centered evaluation for LLM applications. Its focus on user experience and ability to provide detailed feedback makes it a valuable tool for developers and users alike. While limitations exist, such as the computational cost of using large models and the need for dynamic weighting of revision edits, the potential for further development and application across diverse domains is vast. As LLM applications continue to evolve, so too will the methods for evaluating their effectiveness, with revision distance paving the way for a more human-centric future.